Okay, this is my NanoStillery, and I've just finished one batch.
The distillation process
as you can
has
probably
now
hear.
terminated.
And I'm going to give you a quick tour of the machine before we start another one. This is the boiler, and it's got a heating element in the bottom of the tank. Rather than heating elements which protrude into the tank, this is a much safer way of doing it. And
the distillation
as the condenser, it's an air-powered condenser. You can probably hear the fan whirring. Air-powered is much easier than water. You don't have lots of tubes carrying water everywhere. And up here we've got a pump for pumping the cider or beer into the machine and then pumping it out again at the end. And a couple of three-way valves. And down here we have a piece of copper apparatus which is a digital manometer, and it has a pressure sensor in it that senses the level of fluid in the device at any given time, and somewhere near the start of the process it needs to dump the first alcohol that's produced, as it is rich in methanol, and methanol is poisonous. So at the beginning of the process somewhere it will dump it into this little jar. And this other conical flask is the main receiver, so that will collect our alcohol as it's produced. A quick tour of the control panel. We have a
distillation process has now terminated.
Display, a speaker making lots of noise, and if we have a quick look inside, you can see
the distillation process has now terminated.
It's powered by a Arduino Nano, which you can't see, it's behind that circuit board. Here we have
the distillation process has now terminated.
Adafruit's SFX board, which produces the sound effects that you can hear. Down there's a little stereo amplifier. And
the distillation process has now terminated.
Top right corner, power regulator. So close that up. Over here, this is the GPRS transmitter, so this receives the data from the main unit via the I2C bus and translates it over, or transmits it over the GPRS phone network. Inside here we have a little Adafruit GPS feather. As you can see, it's flashing and doing its thing, and a whole load of wiring, and a battery. It's actually powered by the battery, and the battery's charged. Sometimes the device can use up to 2 amps, apparently, spiking.
The distillation process has now terminated.
And to get the process to start from the beginning, just press the
distillation
reset
process
button,
has now terminated,
and hopefully it will start. Let's adjust this knob to give us a little bit of pumping in time. Right, so it's just a pause in the process to allow us to make the necessary settings. So I'm going to bring the pump down to 100 seconds, that's about right, I think. It does have a level switch in the boiler, so if it tries to pump too much fluid into the boiler, it will automatically cut off. But we're only producing, or pumping 1 gallon of dead rat cider into the unit, so it should handle that without any problem. Pumps come on, at the back there, making this horrible noise. So what's happening now is it's emptying the tank before it can fill it. So down here it's emptying the last batch into a demijohn. There he goes. Very noisy. Whilst it's pumping in, I'll just talk about the graphical display that's produced by the Adafruit feather via the GPRS network and onto a web page. This is the graphical interface. As you can see, there's loads of troughs and spikes and curves and stuff, and this represents 4 different temperatures in the machine. Temperature of the boiler, the temperature at the top of the reflux chamber, which is at the beginning of the condenser, and temperature at the end of the condenser, and the temperature in the hydrometer. We've also got a alcohol sensor, so we can sense if there's a problem with the machine, if there's a leak or if it sprays out loads of vapour. The alcohol's actually in blue, so in normal conditions it just should be a nice steady flat line, which it is. Did actually have a few problems in the last batch. As you can see, this graph's sort of fairly convoluted, so it started and stopped. But hopefully this batch will be better and we'll get nice clean lines. Let's just go back to the machine. Okay, it's nice and quiet here now. The pumping out and pumping in is finished. The container with the dead rat side is empty. The boiler will now be probably about half full. We were talking about the temperatures earlier, and there's a temperature sensor in the top of the boiler which goes into the liquids. And this is the reflux tube, by the way, this copper thing here at the top of it. There's another temperature that's called the reflux temperature, and it's just at the top of the condenser. As we go to the other side of the condenser, there's another temperature tapping right at the left hand side of the condenser, and lastly another one down in the hydrometer itself. But sometimes the temperature in the end of the condenser there, sometimes it just gets a little bit high, and the machine's programmed to detect that and shut off the heater. So if it did get too high, basically it's overpowering the condenser and it will produce vapour, alcohol vapour out of the top here, which we do not want. And this little gadget here is the alcohol sensor probe. So if there's any spillages or excess alcohol vapour, it'll detect it and turn everything off. Nothing wrong with alcohol vapour other than it gets you intoxicated and it is explosive, potentially with the correct source of ignition, like a spark or a very hot surface. So, what's happening now? Oh, look, it's like transmitting some data. Let's see if it works. Have a look at this gadget here. See, yep, it's receiving something. And if the top light flashes, then it's actually transmitting to the GPRS cellular network. Let's have a look, fingers crossed. Come on, please. It doesn't always connect. Oh, well, it's working. Brilliant. Okay, everything seems to be working at the moment. The boiler hasn't come on yet, it's just kind of reaching a bit of an equilibrium. Just readjusting any temperatures from the last batch and that sort of thing. But any minute now the boiler should come on. It's a big red light, LED, sort of middle right of the black panel, and that gives off a nice bright light to tell us that it's working. There it is.
Has been turned on.
Excellent, it's working. Great. So the boiler temperature at the moment is 21 odd degrees, I think, 21.11 degrees. Let's have a look at the display. Yep. So those are all our temperatures. Pressure on the top left indicates the level of fluid in the hydrometer. It's been going for 8 minutes now. So the next stage will be the alcohol starts to be produced, and what the machine is going to do is going to detect that the level in the hydrometer is about half full, and it will dump the first bit of alcohol that we produce into this little container here, and that's the what's called the 4 shots. And as I said earlier, it contains a higher percentage of methanol, which is poisonous, so we want to discard that. Fortunately, the machine does it automatically for us, and if there's a fault in the machine, for any reason a fault in the process, we can see it on the graph. So we don't have to babysit it all the time, and can just look at the graph at the end of the process and see that it's done its job properly. Right, I'm going to go and have a cup of coffee and come back when the pressure rises. I've just spotted that the pressure in the manometer is rising, which means we're actually producing some alcohol. So let's just have a closer look at what's going on the display. The red light on the right hand side is pulsing on and off. This indicates that it's gone into low heat mode, so we don't want to overpower the condenser with too much heat in the boiler. So it pulses on and off with a cycle, which effectively reduces the amount of heat that gets into the machine. So if we look on the top left, we've got a pressure reading. I'll just try and get it into focus. 356. When it reaches 500, it should activate the hydrometer dump valve, which dumps the methanol, or the alcohol that's rich in methanol, out of the process. So the condenser temperature, the boiler temperature is 95, pressure is 424, so any minute now. We're 43 minutes into the process.
We are now producing alcohol.
Okay, the machines recognise that alcohol is being produced. Just needs to do the next stage now and dump the 4 shots, which is rich in methanol. Condenser reflux temperature 90.24 degrees. Even though alcohol boils at 78 degrees, the temperature is quite high. It's quite a bit higher than that because there's a lot of water in the vapour as well, so that changes the reflux temperature. Delta T on the top right is down to 2.57. During the rapid heating stage it was up to about 12, I think, so just shows how much reduced the temperature, the rate of change of the temperature is the heating. So we should see the dump valve open in a minute, or we should hear it anyway.
Hydrometer dump valve has opened.
Let's see if we can see the fluid coming out of the pipe. And yes, there it is, just dripping into this little container. There's not much there, about 30 cc's. That's all it needs. Very small amount, but very good technique just to be on the safe side. Right, so on here on the display, the pressure's gone down to 2. And we're back on track for the rest of the process now. Should run nice and smoothly. But before we go and have another coffee, let's have a look at the graphical interface. Most of what we're looking at there in this graph is the previous batch, and as you can see it's all over the place, lots of peaks, troughs. You can see what went wrong really. It was right here where the reflux temperature dipped. I was basically fiddling about there, reprogramming the machine. So what we're interested in now is on the left hand side here, the new data that's been produced. So on the top here we've got a red line which indicates the boiler temperature, and a bit of a curve there where it went into pulse mode and reduced the power, the effective power of the heater. And on the left, the yellow line
is rising.
The yellow line indicates the reflux temperature, so it's just come up to a point there where it's producing alcohol. And down here, see
Now checking all critical systems.
the blue line that indicates the ambient alcohol levels. So when I set the machine up here, which is indicated by this cliff face, I must have
All
spilt.
systems are fully operational.
I must have spilt a little bit of alcohol, and the sensor picked that up. So what I did is I actually opened the window and increased the ventilation so that the ambient levels came down to a more acceptable level. So it's just refreshing. Down here on the left, that's the pressure curve in, if it's purple or pink or something. Let's try and get it focused there. Yeah. So when it does its next transmission, it should produce a nice little spike like this one over here. There. That indicates that the hydrometer has dumped the alcohol that's rich in methanol at the beginning of the process. So what I could do is I could go away, I could leave this process to finish, come back, and I can then look at the graph to see that the process has performed properly, and look to see if there's any errors or any potential errors or any errors which are likely to occur on the next batch. And if the batch that I just produced looked a bit iffy, I could discard it or put it all back through the machine once again. So it's like a really good thing for quality control to look at these curves and just check that the process has gone to plan. You just really don't want to be sitting in front of this machine like all day looking at the LED LCD display on it. It'd be really boring. So we have this instead. There we go, the screen's just refreshed and we are starting to get a spike where the hydrometer dump valve opened and the pressure reading in the hydrometer dropped. Wonderful. And finally, back to the machine after 51 minutes since the start of the process. We're beginning to produce alcohol in the conical flask. Let's have a closer look, see if we can actually see it dripping out of the nozzle at the top. It's quite slow, and there's a reason for that. There you go, just drip, drip, drip. We do not want it to go quickly. We want to do it nice and slowly. If this was a faster process, then it would produce a lot of water. The alcohol that comes out would be a lot more impure. We might get some flavours that we don't really want as well. It's all about the equilibrium in this part of the machine here, the reflux chamber. This is effectively air cooled, and it's actually quite hot. But in here we've got different concentrations of alcohol. As you go from here to here, it's all going to be bubbling around, swirling around and condensing and falling back into the tank, which is what reflux actually means. It means you get some condensation in here and some fallback into the tank. So when it actually hits the top of the reflux device, the alcohol should be purer. You don't want it too pure, otherwise we won't get the desired flavours. So the length of this reflux chamber is quite critical. If it was too big, too long, like a huge great big column, then our flavours would be fairly poor. It still tastes nice, it just tastes like pure alcohol, which has a nice flavour of its own, but in this case we're trying to make cider, or alcohol from cider, which is like a cider brandy. You want it to taste of apples. not just like some kind of pure vodka. So there we go. Okay, we've finished producing our alcohol.
The distillation process has now terminated.
Down here we've got nearly a litre of product, which is fantastic. And
the distillation process has now terminated.
Just to finish with, I'm going to have a look at the graphical interface to check for any problems. So here's our graphical representation of the process, and it looks like it's all gone nice and smoothly. There's no nasty peaks and troughs. The only noticeable thing that we want is this. We want that little peak there, because that represents the hydrometer dump. But other than that, everything looks good. The condensed temperatures remained pretty low, which is the kind of olive green line there. That's remained nice and low at about 25 degrees. So that's good. The condenser obviously wasn't in danger of getting overheated. If we look at the top here, we've got the boiler temperature in red and the reflux temperature in yellow.
The distillation process has
all good.
Terminated.
It's just refreshing. And that's it. End of the process.
The distillation process has now terminated.